What up, everybody? Welcome to another episode of Let's Ask Paul, the podcast where you get to ask me anything you want about the National Electrical Code, electrical theory, whatnot, all by simply going to paulabernathy.com. It's a free resource that's available for everybody over at paulabernathy.com. It's free. It doesn't cost you a dime. And if you've had those issues where you've been on social media, or maybe you've been on Facebook or Facebook group or been somewhere and people post stuff and you're like, wait a minute. That just doesn't seem right. Then guess what? You have a resource, just cut and paste it over at paulabernathy.com, and I'm more than happy to opine about it. And now I could respond in an email to you directly, or if I feel like it's something that many people can benefit from, then I'll turn it into a podcast and share it out with everybody. Again, we want to also go on and thank everybody for listening to our podcasts and sharing it. And again, it's every month after month. It's amazing. Over 300,000 unique downloads. It's just it's been consistent. We did a little bit of a drop and then it goes up and down. But again, we're on so many platforms and we have over 1,000 episodes depending on the platform. And we're just so grateful that people listen to our podcast and share it with other people. And you get something out of it. That's the thing. Because sometimes I'm just rambling and sometimes I'm actually teaching you something. So that's the beauty of my podcast. I'll do whatever the hell I want. So we do appreciate everybody that listens to the podcast, and hopefully you learn something from it. But again, it's free. paulabernathy.com. And again, if you have our mobile app, which is free as well, then you can get right to, under the resources, you can get right to Let's Ask Paul, and you can ask questions directly through the mobile app. But we also have a chat feature on there as well. So you can post a question, post an image. Maybe you're on a job site and you want to post an image of something, you want comments. I monitor it. Schwartzy monitors, Ted monitors, a bunch of great resources on there. We're monitoring it all the time. Not as many people use the chat feature as I would like. I would like it to be very vibrant over there and people sharing things. But, again, some people just aren't as active. So, and I get it. It's all good. But we're going to continue to answer those questions for you. So that's another resource that you can use. Okay, so today I want to talk a little bit about some basic fundamentals that, people struggle with, not just for electrical exams, but in real life. And we'll kind of talk about a little bit of real life scenarios when it comes to things like Ohm's law, series and parallels, and the concepts and what you need to learn, the basics, some rules you got to follow. Now, I will say that, for example, a voltage drop, for those that are listening to this podcast, we have released 2 pocket wallet voltage drop. I shouldn't say 2. It's a card that you can keep in your wallet so that you don't have to remember voltage drop. Again, remember, voltage drop, for example, is only required in things like sensitive electronic equipment and also in fire pump applications. And they are not the 3% and 5% overall that we're familiar with the informational notes in 210, 215, and 230, right? The voluntarily telling you not to exceed 3% on the branch, that type of thing. So these are voluntary, whereas in sensitive electronic equipment, as well as with fire pumps, it's a mandatory thing to take voltage drop into consideration, kind of for the reliability of the circuits involved and whatnot. And you would think that voltage drop, because of that nature, would be more serious in the code in sense of not being optional or a voluntary thing under an informational note. You would think it would be something that would be worked by now into the code. And the reason really that people don't jump and clamor to getting that into the code is that, for motors, for example, motors have overloads. And so again, you've got short circuit ground fault protection requirements and in 430.52 requirements for sizing. But then you have the overload requirement in 430.32 that your circuits are pretty well protected, right? And the motor's pretty well protected. So that's the only one, for example, they say, well, voltage drop can affect motors. Now, it can, and having a voltage that drops below the operating range can cause the motor to prematurely heat up or shut down with the overloads. And that becomes a problem, a bigger nuisance problem, but it probably could, wear on the life of that motor. So people want to take voltage drop into consideration in their design, whether or not it's required or not. And then, of course, you hear everybody talk about voltage drop. Oh, I'm running non-metallic sheath cable across this long run, or these little mega mansions that I see where they run these 14 twos and 12 twos, 150, 250 feet before they even hit the first outlet box. So voltage drop is a very serious issue to take into consideration. But it's not in the code as a requirement. And I know people say it should be, and I encourage all you out there to submit your public inputs for that. And your next opportunity for that's going to probably be around 2027 when we start working on the 2029. Hopefully they start working on it. Hopefully I'm retired by then, but who knows? So at the end of the day, we have those cards available that are fit in your wallet that cover how to size the circular mill, how to size the maximum length and all that. And it even explains to you how to calculate the exact K, which you really don't need to worry about. You just follow what's on the card. You don't have to worry about it. But hey, if you want to know, I do always try to educate. So those cards are available over on our website. Pick up one. I think they're $5.99, and that includes shipping. So it's basically just the cost of producing them, the material and the time, and the shipping's already built in. So check them out over at fasttracksystem.com if you're interested in getting one of those for your wallet. Okay, let's talk a little bit about Ohm's law. I'm sure you all are familiar with Ohm's law. And the concepts of Ohm's law is the rate of the flow of the current is equal to the electromotive force divided by the resistance. Okay, so in most of your Ohm's wheels, and not all of them, people can get creative in the nomenclature they use of an Ohm's wheel. But typically, in most of your basic fundamental formulas for the Ohm's wheel, uses I as the intensity of current, which is what we're going to refer to as amperes or amps. E is the electromotive force. E on our Ohm's wheels refers to volts. So again, some of the Ohm's wheels that you see from people, they'll actually use V instead of E. But, either way, you might see it. Either way, just once you're familiar with the formula flow, it doesn't really matter. R is resistance, and that is in ohms. And then, of course, P is power, which, again, is watts. Right? So the basic formula that you start off with when you're wanting to learn something like Ohm's law, and it'll serve you well because, you could be doing, and I'll give you an example of a practical calculation or a practical aspect to it. And then I'll talk about how this may come into play in a dwelling or something, or a building. In commercial, the engineers probably take care of it for you, but in residential, that's, you got to think about it a little bit, especially now. It's less today with the LEDs that we're installing, but it's still something you have to take into consideration when you're laying out your circuits and things like that for the lighting, for example. So your basic three formulas is if you want to solve for I, which is intensity of current, which is amperes, then it would be just E, which is the voltage, divided by R, which is the ohms. Now, if you want to solve for R, which is the ohms, then you have to have the E, which is the voltage, and you have to have the I, which is the current. And if you want to solve for E, which is the voltage, it's simply E equals I times R. So depending on what you have or what you're trying to solve for, right, is, if I know what the voltage is, and I'm trying to solve what are the amps. If I know what the voltage is and I know what the resistance is, then it's simply E divided by R. Pretty straightforward, right? And good news is for those that are on an electrical exam, typically they give you an Ohm's wheel prior to your test. But some of these formulas are pretty simple to remember in your head. Because in this case, the basic Ohm's law is the three dimensions here. We're not even incorporating power into this yet. We're just talking about E R, and I, right? So to solve for E, you know you have an E and an R left. If you're solving for R, you know you have an E and an I. If you're solving for E, you know you have an I and an R. The only thing you got to remember is when you're doing for I and R, which is amperes and resistance in ohms, then it's division. Okay, it's E divided by R or E divided by I. If you're solving for voltage, you got to remember it's multiplication. It's I times R. Okay, now these are easy things that you can just write down in your code book. If you're in some states that allow you to write things in your code book, or if you're in the field, you can jot these things down. And we also will have a card coming out, pocket wallet card, that will have the Ohm's Law wheel, and a bunch of the formulas on it to make it easier in the field. It's just a pocket handy little deal. That's coming next. Right now we only have the voltage drop one, but we will get the other one in there for you. And these will be made available in a series, so you can get all of them at once, and there'll be a nifty little holder that you can put it in. But anyway, or maybe you don't need it. Maybe you just memorize it and you're good. You're good to go. So those are your basic three formulas that we work with when you're talking about basic Ohm's Law formula. Now, if I had to give you an example, now let's mix in the same scenario that comes, for example, when it comes to power, right? So power, watts, is same example. We can mix this into the mix, because for power you have E times I is going to give you watts power, okay? But if you know what the resistance is in ohms and you know what the current is, then you can also go R times I squared, right? So it's basically the current in amperes squared times R, and that'll give you watts as well. And then also, if you're trying to search for watts and all you have is the voltage and all you have is a resistance, then you can go the voltage squared divided by R, the resistance. So there's quite a additional formulas that you can do for watts, finding out what the watts of power is too, using the same concept. Okay, so let's kind of run some examples so you can get an understanding of what we're doing with it. So let's just say we have an example and we have an appliance that's 1200 watts. And again, traditionally, we're going to be connecting a 120 volt circuit to it. All right, what do we know? We know the watts and we know the volts. Okay, so if you were to look at an Ohm's wheel at this point, is what are we trying to solve for? Well, we don't know what we're trying to solve for the amps, right? And so if you look at it in the variables that you know, and you can say, okay, well, how do I solve the amps? Well, if you solve the amps and you go, okay, well, to solve it, I can go P over E, and that's going to equal I. Okay, so very, very same way we did the voltage over resistance to get I. Here, it's the power divided by the voltage will give us I, right? So, which is the amperes we're searching for. So it's simply 1200 divided by 120, that's 10 amperes. Okay. Now, remember, now that we have all of these variables involved, then we kind of think, okay, well, how do we find out what the resistance is? Because all you gave me was the ohms. We have watts of power, we have voltage, and now we have the amps of the circuit. So what's the one thing missing? Well, what if I want to know, or we're asked, well, tell me what's the resistance in ohms? Well, that's easy. Because now that we have the amp value, we can go back to the original formula, which is R resistance equals E divided by I, or voltage divided by the amperage. So now it's 120 was the volts divided by 10, which was the amps. We just calculated it. And that equals what? 12 ohms. So the key thing to remember about Ohm's law is the ability to be able to work any of the equations out, right? And I'm going to show you some other ways to do this using the different formulas that are in your Ohm's wheel, okay? And our Ohm's wheel is a great thing to get used to have, and it's also great to have that in your pocket as well. So obviously we'll be coming out with a nice little Ohms wheel, pocket edition wallet size card. That'd be pretty cool. Okay. So let's kind of use those numbers since we're just kind of working numbers and see how an Ohms wheel and see which of the Ohms wheel formula that we would use. And granted, you can't see this as the podcast, so I will describe the formula for this, and then it'll make much more sense. So let's keep the variables that we already have. We already know that it was 10 amps. We already know it's 120 volts. We already calculated out the resistance for that is 12 ohms. And we know that the wattage was 1200 watts. Okay. So using these numbers, depending on what's missing, we can show you how you use the formulas to solve any of this. So if you had any of these, at least two of these, then you can solve for something. So let's talk about the amps. Let's find the amps. So let's ignore the fact that we already know what the amps are. What we know is one of the processes of the formulas that we can use is the one for amps where it says that it's the square root of power divided by the ohms. Okay, well, so you're going to solve the watts divided by ohms first before you do the square root, right? So if you ever see that way where you have the square root over and then in the middle of it, underneath it, you have the actual, the watts, and it shows a line and the underneath it is the ohms. You want to work that first. So one of the formulas is the square root of watts divided by ohms. Okay, well, it was 1200 watts and the resistance was 12 ohms. So we divide 12,000 watts divided by 12 ohms, right? And that gives us 100. Then you just hit your square root key on your calculator, and that is 10, right? So that would be 10 amperes. Well, there's another way to solve it. If we already know the wattage and we already know the voltage, then remember, one of the other formulas for solving amps is simply what? Is dividing the watts into the voltage. And that works the same way. So P divided into E. So it's 1200 divided into 1200 divided into 120. That's the voltage. And that equals 10 amps. But there's also another way that we can solve amps. If we know the volts and we know the ohms, then it's 120 volts divided into the ohms, which would be 120 divided into 12. And that's 10 amps. So the three formulas that we use here to solve for amps, depending on what we have in our equation, is that we have to have at least two to work it out. And then once we do that, we open up the doors for, to other aspects of the calculation, depending on what we're working it out as. So for the square root of P over R, where we're solving for I, then that was 1200 divided by 12, which is 100. The square root of that is 10 amps. So it's 10 amp circuit. The other one was the watt, I equals power, or the watts divided by voltage. That was the 1200 divided by 120. That's 10 amps. And then, of course, we have the other searching for the amps. If we know what the voltage is and we know what the ohms are, then it's just 120 volts divided by 12 ohms, and that is 10 amps as well. So it's pretty straightforward solving for the amps and with all the variables that we have in play. Now, when it comes to wattage, it's essentially the same thing. There are three formulas that we use to solve for wattage. The first one is the voltage squared divided by the ohms, right? So if it's same scenario, if it's 120 volts and it's 12 ohms, then it's just 120 volts squared. Okay, so basically 120 times 120. Okay, and which is 14,400. Think about that. When you see 120 squared, it's just 120 times 120. That's all it is. All right, so 14,400, and then you divide that by 12, because 12 would be the ohms of resistance. That gives you 1,200 watts. So we can find the watts as long as we know the voltage and we know the resistance. We can find wattage. Another way to do that formula is the simple formula that P equals E times I. And in this case, you're going to use the formula that you have the answers. In other words, the data that they give you in the question is what you're going to determine which formula you use. So if we are given the voltage and we're given the amps, then we're going to use the formula where P, wattage, equals volts times amps. So in that case, it's just 120 times 10. That's 1,200 watts. Now, maybe they only give you the voltage. No, excuse me. Maybe they only give you the amperage. And maybe they only give you the ohms. Okay, well, we can solve it that way too. The amps. And so in our case, it's 10 amps. So it's 10 amps squared. Okay, so 10 amps times 10 amps is 100 times 12. And that is 1,200 watts. So again, my point here is you're going to learn the different formulas and you work with what you have. Now, maybe they give you what you need to do in order to be able to get another equation. Maybe they don't give you the amps, but they give you everything to solve for amps. And then once you solve the amps, then you open up the door to be able to do other calculations to find the answer. Right? And so the next one is volts. And volts is the same way as we kind of did for amps. The volts, one of the ways to solve this, if they give you the wattage, then it is wattage times resistance. In this case, it's 1,200 watts times 12 ohms of resistance. So you do the wattage times the resistance, right? And that'll give you a total of 1,200 times 12, and that's 14,400. And then it's the square root of that. So in our case, it'd be 1,200 times 12 is 14,400. The square root of that is 120 volts, and that's what our voltage is. Now, of course, if they give you the amps and the ohms, in our case, 10 amps, and they give you the ohms of resistance, in our case, it was 12 ohms, then to solve for voltage, one of the equations is just I times R. So 10 times 12 is 120. Or maybe they give you one where it gives you the watts and it gives you the amps. And so, okay, so it doesn't give me the resistance, but it does give me the wattage and it does give me the amps. So I can use the formula P divided by I to solve for E. So P being 1,200, that's the watts, divided by 10 being the amps is 120. And to round this out, the ohms, it's essentially the same way as the wattage were done. Makes sense, right? So find the resistance. If I know what the voltage is, 120 volts, and I know what the wattage is, 1,200 watts, then I can solve for resistance by going voltage squared divided by 1,200, which is the wattage. So it's E squared divided by P, which is the watts. So that would be 120 squared, and we already know what that is, 120 squared. So 120 times 120 is 14,400. And then you just simply divide that by the wattage, which was 1,200 watts. So divide that by 1,200, and that is 12. And that is the ohms. So they could ask you the question when they say, well, we want to solve for the resistance in ohms, and we'll tell you the amps, and we'll tell you what the wattage is, right? Okay, so they didn't tell us what the voltage is, but we don't need it. We have enough variables to solve it out. So in this scenario, it would be, R equals P, the watts, divided by amps squared. Okay, so it would be 1,200 watts divided by 10, which was the amps squared. Okay, so all you do is do the 10 squared first. 10 times 10 is 100, right? And so then you got the 1,200 divided by 100, and that is 12 ohms. Makes sense? And then lastly, it's if you're given the volts and you're given the amps, then it's just easy, right? It's just a normal, traditional equation that we did, E over I, okay? So it's simply 120 is the E, which is the voltage, divided by 10, which is the amps. And so with your calculator, you just do 120 divided by 10, and that is 12, and that is it. 12 ohms. So trying not to make it very complicated, because it's not complicated. One, it's helpful if you have the formulas. So the whole point of this episode is not to expect you to listen to it and understand the Ohm's law process by remembering what I talk about what I mean is, go and see if your state allows you to mark these in your code book, right? And if they do, then you want to put all of these formulas in your code book, typically up near the front where you have the code panel members, because you got a bunch of area to write. There's blank spaces there. That's the best place to do it. And that just gives you the greater opportunity to be able to have it right there handy for you. If you're in a location that does not allow you to write in your code book, then just remember some of the fundamentals. Go over it, listen to it again, review your Ohm's wheel, your power wheel, learn these different formulas, and then it'll make sense to you as you get into it. But it's the low-hanging fruit on an electrical exam where they ask you something and it may seem like it's complicated, because they might say you have 2 light bulbs, and nobody uses that terminology anymore. It's lamps, but you get it. They might say it's 200-watt light bulbs, and so that's 200 watts of load. And okay, you can solve it, because now we know what the wattage is, and they'll tell you what the circuit is if it's a 120-volt circuit. So you have the foundation to be able to calculate it out. And you may think, well, I'll never have an Ohm's law situation in my career, but on an exam, you very well could. And so that's the reason why we brought that up today. Now, in the real world, when would you run into needing this as far as understanding what the amps are and all that? Well, you know what? If you have a lot of luminaires that you're putting on a circuit and have a specific load, and this was a bigger deal back when we had normal incandescent and things like that, we had to worry about our loads. Not so much now with the LEDs and the CFLs and all these really low wattage loads. It's not as critical. But understanding Ohm's law is a foundation that electricians have to go through, whether you're an apprentice, helper, even a journeyman striving to be a master. These are fundamentals, and we just always, and we forget them. It's one of those things where as you don't use it, you lose it. So you just kind of got to go back through and refresh your memory, kind of get another feel again for these formulas. And things like that. Rest assured, folks, if you want that quick and easy in your pocket, we will be coming out with the Ohm's law wheel and the formulas. One side will be the wheel, the other side will be the various formulas and examples. That'll be a nice little pocket edition. So look for that soon over on fasttracksystem.com and check that out. Okay. All right. That's going to be all for today's episode. Just kind of talking about Ohm's law in those scenarios. I do have a podcast coming up that will be talking about the basics of series and parallels and combination circuits. And just kind of, since this is kind of one of those things that are really hard to do over a podcast, it would just be a casual conversation talking about them with the understanding that you will need to do a little bit of extra study. We do have videos on this over on Fast Tracks Tube, series and parallels and all that kind of stuff. And we even have some recordings from our Wednesday night sessions that are available up there that you can watch. And again, we go a little deeper into it and that type of thing. So, all right, folks, hopefully you got something out of today's episode. I didn't bore you to death. Who knows if you'll listen to an entire Ohm's Law podcast, but hopefully you will. Till next time, folks, stay safe. God bless. And oh, by the way, drop me a note telling me you listened to this whole thing. That'd be awesome. Take care.